Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering Module 4, Inquiry Question 1, the 2019 QATs Year 11 Physics paper, Question 22. Let's have a look. So in the first question, we have a diagram below that represents parallel electric plates. We want to draw lines on the diagram to show the nature of electric fields in charged plates. Now we know that according to the formula, and this represents electric field strength of two charged plates is given by the voltage divided by the distance. So this is kind of the proposition we have here. Notice how E is constant in that fact, because throughout this entire plate we have the same voltage. They're separated by the same distance. Okay, so what we'll have is lines that are equally spaced, or at least I'll attempt to draw lines that are equally spaced from each other. Okay. The only scenario where the electric fields aren't evenly spaced is the lines just outside the plate, and they will vary just a touch slightly from each other. Next thing we need to draw is the direction of the electric field. Now the idea is we always go from positive to negative, so high potential to low potential here. So our arrows are pointing down like so. Okay, so that completes our first question. Question B, if the distance between the plates is 5 centimeters, calculate the magnitude of the electric field between the plates. So electric field strength is given by the change in potential divided by distance. Our change in potential is 40 volts. The distance we have is 5 times 10 to the power of negative 2 meters. Okay, just remember, distance is, the SI units for distance is meters, so just make sure you get the correct conversions going for that. If I plug it into my calculator, the answer of the electric field I get is 800. If we look at the units, it'll be volts per a meter. Okay, and then we go to our last question here. It says, calculate the direction and magnitude of the acceleration of a particle with mass 2.7, 10 to the power of negative 20, with a charge of so, placed in the field 2 meters above the bottom plate. So this kind of spot here. So we want to find the overall acceleration. Okay, we already know what the electric field strength is. The electric field strength is 800 volts per meter. We want to firstly work out the force that is being placed onto our charge particle, and then from there we can work out the acceleration. The 2 here doesn't really factor in too much. The reason being is because the electric field strength is uniform throughout the plate, so it doesn't really play much of a part for us here. Okay, so let's firstly find force. The charge is positive 160.2, 10 to the power of 19. Okay, and then we have an electric field strength of 800. So let's do the calculations. So the amount of force exerted on our charged particle here is 1.2816, 10 to the power minus 14. The units here is obviously force. We're going to leave this as positive because that's showing that our charge is going to go to the lower potential plate or the negative plate. Next is to find out the overall acceleration. So we know what the mass is. I'm going to write it down here, so when I scroll down I remember what the value is. Okay, 2.7, 10 times the power 20. So you can substitute your values in, or you can just rearrange. So the rearranged equation we get is acceleration is equal to force over mass. So that's what I'll write. and then I know that the force is the value I calculated from above, and this is the mass of my particle. Okay, so the overall acceleration I would get, if I plug it into my calculator, is this value here, which is incredibly fast. If we look at the question, the lowest sig fig we actually used is 2. So you could round it off to 2 sig figs. So it'd be 470,000,000, so 4 zeros, meters per second squared, and then we can write the direction towards 0-volt plate, which is this plate over here. So hopefully that explains to you how to do questions related to electric field lines and Coulomb's law. Please give this video a like to support other videos coming out soon, and much support appreciated. Thank you.